final example we're going to talk about tonight is going to be triple bonding. To do triple bonding, we're going to use CH. Alright, now CH, instead of, believe it or not, it's going to have 2 carbons and 2 hydrogens. The reason we're doing this is because it's really C2H2, but using simple whole number ratios it boils down to CH. Alright, now carbon has 4 valence electrons. Well, we're going to take up 3 right there just like that. That's the triple bond. Now that other carbon valence electron is going to be shared with the hydrogen here. And what that does is now you have all the valence electrons taken up. And that is how you do a triple bond.
Okay, before we begin talking about Lewis structures and covalent compounds, a Lewis structure is diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Lewis structures can also be drawn for any covalently bonded molecule as well as coordination compounds. What is a covalent compound?
Well, Shelby, a covalent compound is a chemical bond that involves the sharing of electron pairs between atoms. The stable balance of attraction and repulsive forces between the atoms when they share electrons is known as covalent bonding. By sharing electrons, 2 atoms can mutually complete their valence shells to become more stable. Alright, now our first example we're going to use for covalent compounds is going to be CF4. Alright, as you can see, that right there tells you that there's only 1 carbon atom. Now CF4 tells you there will be 4 carbon atoms. Now carbon has 4 valence shell electrons, which you position around it. Now, fluoride, with the 4 atoms it has 7 valence shell electrons. And what we're going to do, the first thing, is we're going to link these 2, well actually, really, 5 together. Now that that's done, we're going to go around and we're going to position the rest of the valence shell electrons. Now, to make this complete, every atom wants 8 electrons to make the valence shell electrons to make them stable. And what that does, it makes them less reactive to other stuff that's out there. Now, what these lines right here represent is 2 valence shell electrons. So that means that they're now linked. And these now share those 2, so what it is you count 2, 4, 6, and 8. That's pretty much how you do CF4. Alright, now for the second example, we're going to talk about double bonds. Double bonds are where instead of 1 of the lines, there's 2. Now, our example is going to be CO2. As you remember from the first example, carbon has 4 valence shell electrons. Oxygen, though, only has 6. Since there's 2 atoms of oxygen, that means there's 12 valence shell electrons for oxygen. Now, when you write it, you would put the oxygens on either sides of the carbon. Alright, you would draw the dashes symbolizing the 2 bonded valence shell electrons, and you would draw out the other valence shell electrons, and that is wrong again. In case you're wondering why I'm erasing because what I just drew was too many valence shell electrons. Don't do that, they'll screw you up. Alright, now, instead of having just these, there's also 2 more valence shell electrons for carbon. What we're going to do is we're going to have another dash put in right here and remove said valence shell electrons. Alright? Now this is not what it looked like. This is just showing you how it be. When you do it correctly and everything's finally done, you would have carbon, oxygen, oxygen. What looks like an equal sign, but remember those 4 valence shell electrons being shared there. And then you would have the 2 pairs done kind of at an angle. That's just for symmetry, just trying to clean it up for y'all. And there's how you do CO2 for the Lewis structures.